Alright. 1.8, we're dealing with combinations of functions and compositions of functions. We've talked about the combinations of functions dealing with either the sum, the difference, the product, or the quotient, and we've dealt with these rules. I'm not going to spend a long time on those. I will do one example later on, or we'll just do that one right now. If you look at, I'm going to do one from the book, number 10. Which gives me two functions. It says that f of x is square root of x squared minus 4, and then it tells me g of x is x squared over x squared plus 1. And I want to find all of four of those, the add, subtract, multiply, divide. So for f plus g of x, I'm going to go ahead and take those and add those together. And if I do the square root of x squared minus 4 plus x squared over x squared plus 1, there's not a lot to do there. And I could try to work to get a common denominator of x squared plus 1 and add them all together, but honestly that's probably just going to make things messier than if I just leave it like that. Now if I do f minus g of x, similar sort of thing, just instead of plus I have minus. And once again I could try to get common denominators and add that all together, but I think that we'd be biting off more than really worth it. Now let's do f times g of x. So I have the square root of x squared minus 4 times x squared over x squared plus 1. I would probably combine that into 1 so that I end up with x squared square root of x squared minus 4 all over x squared plus 1. And then for my final one, going f over g of x, which would be square root of x squared minus 4 over superfraction x squared over x squared plus 1. Now that is hideous. That's awful. I would never encourage anyone to write a problem actually like that. So instead of doing something over something, let's think about it like divide by x squared over x squared plus 1, which really is the same as multiplying by the reciprocal. So I have x squared minus 4 times x squared plus 1 over x squared, which then, when I combine those into one nice, neat function, at least one fraction, I would have x squared minus 4 times x squared plus 1 all over x squared. Now then, for that last one, it says, what is the domain of f over g of x? And that would be this function right here. What is the domain of it? Well, I can plug anything into the top and I'm fine, because if I plug a negative into x squared, it's going to become a positive, so I don't have to worry about the square root. But the bottom can't be equal to 0. So if that means that x squared can't be equal to 0, then that means that I have all real numbers except 0. Because if I plug a 0 into the equation, I'll end up dividing by 0, and that gives me a number, or gives me an undefined problem. Next one we're going to talk about is compositions of functions. And the compositions of functions is where I have this f of g of x. And again, that's f of g of x, right? Which really I like written more like this. I think that's a really pretty way to write it. And we're going to look at a problem off of this. So let's go look at this one here, which may or may not be number 31. They tell me that f of x is equal to x squared, and they tell me that g of x is equal to x minus 1, and they want to know a series of compositions. The first one being they want to know f of g, which I would then rewrite as f of g of x, which is f of my g of x is x minus 1. So now if I think of x minus 1 going into that x squared function, it's taking the place of the x, I have x minus 1 squared, which you could FOIL it out and end up with x squared minus 2x plus 1, or you could leave it as x minus 1 squared. Either way is really fine. Next, they're asking for g of f, which I would rewrite as g of f of x. I think it's so much neater. And so that gives me g of x squared, because f of x is x squared. So therefore I'm going to take the x and replace it with x squared. And now I have x squared minus 1. And that's it as far as that one goes. I guess you could technically factor that into x plus 1, x minus 1, if you wanted to. Again, just throwing some extra answers out there. I believe the ones that would be in the books would be these. They're not asking for the extra simplification. That's just more of for fun. And then the last one is f of f. So I'm going to do f of x, a composition of a function inside of itself. So I start with, this would be then, really I'm looking at f of x squared. So I'm going to take the x squared function and plug an x squared in for x. So that becomes x squared squared, because originally it was x squared, and x squared is going in for the x. So x squared squared would end up being x to the 4th. Good. Those are compositions of functions. Alright, now on to more compositions of functions. They just throw a few other things in there, like domain. So for this one, they want us to find f of g and g of f, but they also wanted to know the domain of each individual function and the composition of those functions. So for instance, this one, f of x, is great. That's just all real numbers. There's nothing wrong with any of those, so that's just all real numbers. That's a really ugly symbol. Let's try that again. All real numbers. And then over here, there are some numbers that won't work, because if I plug a negative in there, I'm going to get an imaginary answer. So this one would be x has to be greater than or equal to 0, or 0 to infinity. Either one of those would work as a domain there. Now let's find f of g of x, right? Or the way that it is written there, fog, right? F of g. So f of g of x would be f of the square root of x, which would then give me the square root of x squared plus 1. Now then, square root of x squared is going to cancel, and I would be left simply with x plus 1. Now, what is the domain of this function? Well, we'd like to say, just look at this last one, and x plus 1, well, it's all real numbers, but not quite so fast, because I got to think of, if I were to plug a number into here, what numbers could I plug in? What numbers could I plug in for the x there before the square root squared happened? Well, that's going to follow the same rules as this one up here. And so the domain for f of g of x would be x has to be greater than or equal to 0. Now, let's do g of f of x. So g of f of x would be equal to g of x squared plus 1. So if I take that and plug it in, I have the square root of x squared plus 1. So now what's the domain of that? Well, I can plug any number into here and it's going to be positive. And positive plus 1 is still going to be positive. So this entire thing has to be positive. And can you take the square root of a positive number? Sure. So this would be all real numbers once again. So g of f was all real numbers. F of g was numbers greater than 0. And then those top two ones we already did. Good. Now, these are all the basic ideas for compositions of functions for the algebraic approach to them. Again, I'm very sad that I didn't assign any of the graphing ones, and I might have to remedy that with a little bit of an extra homework assignment here in the near future. because the graphing of the compositions of functions and the combinations of functions is really, really important as well. So, yeah.